Hello, everyone. My name is Dr. Leilani Battle, and I will be presenting database benchmarking for supporting real-time interactive querying of large data. Whether talking about commercial systems like Tableau or academic systems like CDB and others, we find that exploratory visual analysis, or EVA, is often considered the first step in a human-centered data analysis process. A natural question for the database community is whether DBMSs, or database management systems, are truly capable of supporting interactive real-time data exploration. To answer this question empirically, ideally, we want three things: realistic visual exploration scenarios, concrete performance measures, and a consistent, repeatable evaluation procedure so that we can fairly compare multiple systems together. In other words, we need benchmarks. So in considering exactly what use cases to study and to benchmark an exploratory visual analysis, cross-filter stands out as being particularly demanding. For example, we find that in the visualization and database literature, cross-filter is called out as an important interaction technique to support real-time interactive exploration, demanding response times from the underlying system of 100 milliseconds or less, and motivating optimization techniques like approximate query processing. But what is cross-filter and how does it work? So here's an example with a user exploring on-time flight performance data using a cross-filter system developed at the University of Washington called Falcon, which we also use for our study. Here, the user is exploring 6 different attributes, each visualized as a different histogram. And the user can interact with these histograms using what's called brush filters. For example, here the users created a brush filter over the departure delay attribute. As they manipulate this filter, all of the other visualizations are updated in real time to show the data that's being filtered for. The user can also create additional filters to enrich their exploration. For example, here the user is drawing a filter by dragging over the distance attribute histogram. And as any of these filters are manipulated, the results are shown in real time as the interaction is happening. So given this use case, how are existing benchmarks supporting or not supporting it? We find that existing DBMS benchmarks like TPCH, TPCDS, and the star schema benchmark, or SSB, tend to simulate data warehouses and not spontaneous interactions with exploratory visual analysis interfaces. In contrast, we do find that visualization benchmarks contain interaction data for realistic EVA scenarios, but they lack any runnable infrastructure that we can use for actual systematic benchmarking purposes. So in response, we present a new DBMS performance benchmark to start filling this gap. Our benchmark was derived directly from real user traces, where we conducted a user study with 22 participants and 3 real-world data sets. We analyzed the interaction patterns that we observed, and we discussed and summarized the implications for DBMS design. We then took our 128 traces from our study and translate them into a runnable benchmark, where our benchmark was used to test 5 different systems. We find that none of these systems that we tested provide satisfactory performance for cross-filter use cases, even with a modest dataset size of 100 million rows. First, I'll start talking about our user study, where we had 2 questions we wanted to answer. What, if any, patterns do we see in how users interact with cross-filter interfaces, and what are the implications for DBMS design? So we had 22 participants using Falcon to explore 3 different data sets: movies, on-time flight performance, and weather data. For each data set, each participant completed 4 different tasks, where the tasks varied in complexity, and they varied in terms of open-endedness or how exploratory the task was. So I will not go into all of our user study results here. Please see the paper for more details, but I will call out some high-level points. So first, we find that cross-filter encourages rapid continuous interaction. For example, we found that dragging of brush filters is the most common interaction type used by our participants. So here we have a bar chart where on the y-axis we have the different interactions that participants performed. And on the x-axis we have the total number of interactions we observed per type. We see that dragging of brushes was twice as common as the other interaction types. We also find that higher complexity tasks tend to lead to more interactions being performed and then less time observed between interactions, meaning that participants spent more time exploring and less time thinking about how they were going to do it. So here we have box plots where on the x-axis we're seeing the distribution of total interactions that participants perform per task, divided by data set explored and the complexity of the task on the y-axis. So we see here that in general, more complex tasks tended to lead to more interactions being performed. We also find that cross-filter leads to high query generation rates. For example, we find that dragging of brush filters produces the most queries. And on average, dragging brush filters can produce 174 queries per second for just one visualization. So why is this significant? Let's consider our on-time flight performance example again, where here we're talking about manipulating a brush filter over the distance attribute at the center of the visualization. Whenever we manipulate or create this filter, we're not updating just one visualization. We're updating 5 visualizations. So in reality, we have to take this number 174 and multiply it by 5 for our on-time flight performance use case. So how do we take our interaction data and translate it into SQL queries that can actually be executed on a DBMS? To do this, we use IDE Bench. Specifically, we took our interaction data and wrote specifications that IDE Bench could interpret and then use that information to translate our interaction data into SQL queries automatically. We also used the data generation feature of IDE Bench to scale our data sets up or down for performance testing purposes. And we tested 3 different data set size cases: 1 million, 10 million, and 100 million rows. We also tested with 5 different DBMSs as part of running our benchmark. So now I'll talk a little bit about results. So again, I'm not going over all of the results here. Please see the paper for more details. But specifically, I'll talk about what stood out the most to us, particularly the response rate metric that we calculated. So response rate means out of all of the queries issued by the cross-filter interface, what percentage of them were successfully completed by the DBMS and completed on time, where on time means within a response time threshold of 100 milliseconds. So we see that in the smallest dataset case, 1 million rows, the best performing system, DuckDB, performs very well. It has a response rate of 93 or 94%, meaning at most 7% of queries were dropped. But what gets interesting is when you look at how the performance changes as the data sets get scaled up. So in this case, the 100 million rows case, we see that DuckDB is still the best performing system, but we see a huge difference in the response rates. In particular, the best performance we see is 29% response rate, meaning that 71% of queries were not completed, not executed, or not completed on time, which is pretty surprising. So the overall takeaways from this work are that we found that users want support for highly interactive exploration environments. If you give users access to highly interactive widgets, they will make good use of them. And this point is corroborated by earlier work on cross-filter interfaces in the human-computer interaction and visualization communities. We also find that visualization use cases pose significant DBMS performance challenges. So cross-filter interactions, for example, can generate hundreds and possibly thousands of queries per second. Finally, Cross-filter is just one of many possible use cases within exploratory visual analysis. We are not arguing here that one benchmark could or should represent all of these cases. Instead, we argue for an ecosystem of benchmarks. So in summary, as a community, we understand analytical benchmarks are important because they enable systematic evaluation of DBMSs. But no benchmarks exist for exploratory visual analysis scenarios. We present a new DBMS performance benchmark to start filling this gap, where we conducted a user study with 22 participants exploring 3 real-world data sets to collect data for this benchmark. We analyzed that data and characterized interaction patterns observed and discussed the implications of our results for DBMS design. We then translated these results into a runnable benchmark and tested that benchmark with 5 different DBMSs. We find that none of the DBMSs tested provide satisfactory performance for cross-filter use cases, even with a modest data set size of 100 million rows. And in the future, we argue that we need an ecosystem of performance benchmarks for EVA, not just one benchmark. So thank you so much for listening. If you have questions, please feel to reach out over email. My email is here. And then our benchmark is publicly available online through our OSF repository. Again, thank you.